Okay, so now we're going to be discussing systems of simultaneous linear equations. Yeah, so you might have heard of this or you might have seen this already. So you know, like for example, when you have, for example, 2x plus y is equal to 6, and then you have 3x plus 2y is equal to 10, for example. Yeah, they have these two, they're set up, and then you're supposed to solve for x and y and find out what they are equal to. Yeah. Now, obviously, you can have another, and you can have even another one, yeah. So you can have like let's say 4x plus 2 plus y, for example. Sorry, plus y is equal to 2. Yeah. So you can have this one. By the way, I'm creating some random example that this could be really wrong, but anyways. So you can have yeah a three simultaneous equations as well, right? So there's two types of systems that we deal with. There's the 2 by 2 system and there's the 3 by 3 system. Yeah. Now, generally, we are going to first of all, before we delve deeper into these systems, we need to check out some sort of general rules for a system of equations. Yeah. So so for a general system of simultaneous equations, n times n can be any, number or constant, you have three like scenarios, yeah? So three cases. So what are your three cases? The first case is that you have a unique solution, okay? Solution. Your second case is that you have no solution. And then your third case is that you have infinite solutions, okay? So you have three cases and you can, come across any one of them, yeah? So Um, we're going to we're going to delve deeper into the 3 by 3 system of simultaneous equations first, because I think it takes longer and I would like to discuss it first. So yeah, I have three different system of simultaneous equations, and all three of them represent the three cases that we're going to talk about. Okay, I'm not going to say which ones represent which, because I want to take you through the whole process naturally, as if we're just working it out and seeing how it is. Yeah, so we'll go into that. Yeah, so. Um, okay, so here we go. First of all, let's write down our simultaneous equation. So we have 5x plus 11 y minus 21z is equal to negative 22. Okay, then we have x plus 2y minus 4z is equal to negative 4, and then 3x minus 2y plus 3z is equal to 11. Okay, so we have these three simultaneous equations, yeah? So, system of simultaneous equations, 3 by 3 um, system. Okay, so now I want to work out for x, y, and z. I want to know what x, y, and z are. So what am I supposed to do first? Well, first of all, you can look at your system of equations and sort of simplify it. What I usually like to look at is to see if my first row, my first row of simultaneous, like my first simultaneous equation, if it starts with 1, yeah, if it has like its coefficient of x is 1, yeah. If usually it isn't, I'll look at the other two and see if I can find a coefficient of x which equals to 1, yeah. And in this case, it's in this equation right here, right? So a part of the rules or what you can actually do before you start solving a system of linear equations, simultaneous equations, is that you can actually switch them around however you'd like. Yeah, it's up to you completely what you want to do. Yeah, so you can switch them around. So I'm gonna switch around these two over here, okay? Because I would like for this system of equations to be, for this equation to be number 1, and then the others following it, okay? So, um, I'm gonna go ahead, I'm gonna come here. So I'm gonna say x plus 2y minus 4z is equal to negative 4. And then after that, I'll write the 5x plus 11y minus 21z is equal to negative 22. And then finally, the last one, 3x minus 2y plus 3z is equal to 11. Okay, so just replace this. So plus. Okay, so now this is our system of simultaneous equations, and now we can start solving, yeah? Okay, So first of all, I'm going to introduce something called the matrix system or the matrix. Um, yeah, a matrix system, where you basically take all the coefficients that you have and you just write them in sort of like a square bracket. And then after that, I'll explain what you actually do. So this simplifies the whole thing because then you're just dealing with numbers. You don't have to deal with the x's and y's and z's and so on. Yeah. So first of all, look at your first row. Yeah. So what's the coefficient of x? It's 1, right? What's the coefficient of y? It's 2. What's the coefficient of z? -4. And then you take your last number and say -4. Yeah, so see how I'm writing them freely? That's how it's going to be for every single, like the other two equations too. So let's look at this. Coefficient 5. Coefficient of y is 11. Coefficient of z is -21. And then last number is -22. Then for the last equation, the coefficient of x is 3, coefficient of y is -2, and coefficient of z is, oop, it's not z, it's 3. And then the last thing is y. Okay, sorry. 11. Okay, cool. So now we have this. Now you usually draw square brackets around these numbers like so, and then you add a vertical line to separate like the system of equations here from their answers basically. Yeah, so let me try to make that more straight. Okay, I tried. Okay, cool. So now we have this. Now we can actually start working out for our values, or we can start creating a sort of like system which we can then use to easily find our variables or easily find our values x, y, and z. Okay, so we're going to use something called I need to write this. So it's called the Gaussian elimination. I don't know if I'm saying that correctly. Gaussian elimination. I'm going to assume that I'm saying that correctly. Hopefully I am. So we're going to use the Gaussian elimination. What is that exactly? Well, it basically says that you want to take your three values over here in this little corner, the triangle here. Yeah, okay, let me actually draw the triangle. There we go. Yeah. So you take these three numbers over here and you want to turn them into zeros. Okay, so you want this 5 to be a 0, you want this 3 to be a 0, and you want this -2 to be a 0. Why? Because later on it helps you a lot, because then you're just going to have, like, imagine we turn this back into simultaneous equations. You're going to have 0 and 0, so that means that your y and x are canceled out, and you only have z. So you're going to have what? Let's say, for example, 3z is equal to 6, for example. Then you're going to be able to solve it. It's going to be z is equal to 2. Yeah, so it's going to be really easy. Yeah, so this is what we want to do here. So we want to turn these three into -2. So usually the approach to it is you don't try to make them 0 altogether just at once like that. No, you start with these two. So start with these two and say, okay, I want to turn these two into 0. And then after that, focus on this little guy here. Okay? Updating this component. Oh, okay. So now, what are we going to do to transform these two into 0? Well, I can use my first row. I can manipulate it, yeah, in order to set up like an equation or like a matrix where I can like I can set up. Let me try to explain it by actually doing it. Look, I want to get rid of 5. Okay, what number can I multiply 1 by to so that when I add 5, it's going to be equal to 0? -5, right? Because -5 plus 5 is just going to be 0, right? Okay, so that's good. So that means that I need to turn this variable into 5. Now, -5. So if I'm going to multiply this by -5, that means I have to multiply this entire row by -5. Okay, cool. So that's how I can get rid of this variable over here. Yeah? Now, what about this one? Well, I can also use the first equation. Yeah? But in this case, I'm going to multiply it by -3 because -3 plus 3 is going to give me what? 0, right? So I can use this, I can manipulate it in such a way to get rid of my 5 and 3 for these two rows. Now the thing is, the way that I'm manipulating it is not going to change how it actually is. Yeah? When I write my new matrix, it's going to be the same. Okay? So wait. before we move on to actually showing you the new matrix, this is how I'm going to write it, okay? So we denote these guys as rows, yeah? So R. So this is row 1, row 2, and row 3, okay? So row 1 is going to be the same exact, it's just going to be the same exact thing, okay? Now, row 2, what are we going to do with row 2? We're going to multiply row 1 by -5. So we're going to say -5 row 1 and then add row 2 to it. And what is that going to give us? Our new row 2. Okay? Same thing with row 3. What are we going to do to row 1? We're going to multiply it by -3. So -3 row 1. And then we're going to add row 3 to it in order to get our new row 3. For this one, this is just going to be the same. Yeah, just row 1. Okay? So, therefore, when we come here to write our new matrix, it's just going to be 1, 2, -4, -4. Create this line over here, and that's it. Row 1 moves on to be the same exact way it has been, yeah? Even though over here we're manipulating it, yeah, we're only just using it as like some sort of like resource in order to turn these two values into 0, but it doesn't actually change in the matrix, okay? Cool. So, or in the matrix system. So, now, what are we going to do? I like to usually come like here, and I'm just gonna delete this. So I like to usually come here somewhere and do my calculation right under here and then copy it here. So I'm gonna follow this exactly. So -5 times row 1. So I'm gonna multiply every number here by -5. So -5 times 1 is -5. -5 times 2 is -10. -5 times -4 is 20, and then it's 20 again because it's -4. So this is my first row. Then I'm gonna add row 2. What is row 2? So I have 5, 11, -21, -22. Okay? So that's that. So now, 1 second. Let's take it like this. Okay. So now I'm going to add them two. Yeah, so this is going to be 0. -10 plus 11 is going to be 1. And then 20 minus 21, yeah, is going to be -1. And then 20 minus 22 is going to be -2. Yeah? Cool. So then I'm going to write this. This is my new R2. So this will equal R2. So when I do the addition for these two, this is my new row 2. So I'm going to put that in. So I'm going to say 0, 1, -1, and -2. Perfect. So let's erase this and go ahead and do the third one. So for row 3, I'm going to multiply row 1 by -3. So this is going to be -3, -6, and then 12, 12, right? Then I'm going to add the third row. So 3, -2, 3, and 11. Okay? There we go. Add. -3 plus 3 is going to be 0. -6 minus 2, because plus minus is going to turn into minus, is going to be -8. 12 plus 3 is 15. And then 12 plus 11 is going to be 23, right? So I'm going to go ahead and I'm going to copy that into this matrix. So 0, -8, 15, 23. Perfect. So let's erase all this. Okay, so now we're going to come over here and we're going to draw the square brackets. There we go. So this is now our new matrix system. Okay, so now I look at it, and now what I need to do is to turn this into 0. Yeah, so this is my last step. After that, I can then solve for my actual variables x, y, and z. Okay, so how am I supposed to do that? Well, let's look at the first row again. Yeah, I want to add something to this row. I want to add something to -8 for it to be 0. So what am I going to add? I'm going to add, well, 8, right? So what 2 times what gives me 8? It's 4. But notice this. If I multiply this by 4, that means that this 1 over here is also going to be 4. So this is going to be 4, 8, -8, -8, right? And then when I do plus or minus, I'm going to actually then change my third row. I'm going to change the 0. It's going to be then what? 4. Yeah, or -4, depending on which one I choose. But I don't want that. I want this to stay at the 0, right? So instead, I'm going to use row number 2 because look at this. We have a 0 right here. Anything multiplied by 0 is going to be 0. So therefore, I'm going to take this value over here. Yeah? What is it? What am I going to multiply it by? I'm going to say this is going to be 8. Okay? So the way that I'm going to change this row right here is I'm going to say row 3. Sorry, no. The row that I'm changing is the last one. Yeah? So it's going to be row 3 plus negative, sorry, it's not negative. It's going to be plus 8 times row 2. Yeah? So let's see how that happens. So 8 times row 2. So let's work that out first. So, well, okay, let's write it like how it's here. So this is going to be equal to our new row 3. So this is going to be 0, negative 8, 15, and 23. This is row 3 right now, right? Now, 0 times 8 is 0. 1 times 8 is 8. 1 times negative 8, no, negative 1 times 8 is negative 8. And then negative 2 times 8 is negative 16. Okay. Now, we're going to add these two together, right? So 0 plus 0 is 0. Negative 8 plus 8 is 0. 15 minus 8 is going to be 7. And then 23 minus 16 is going to be 7 as well. Okay? Cool. So then that means that our last row is going to be 0, 0, 7, 7. Oops, 7s are too close. 7, 7. And then we just write everything else as is because it stays as it is. So 1, 2, negative 4, negative 4. Okay, so this is our new matrix system. Okay, so let's zoom in. Now, we have the 3 zeros. We have the triangle here in this corner, which is all zeros. Okay, this is what we wanted. Now we can start working out for our values x, y, and z. So what I'm going to do over here, I'm going to come here, I'm going to say this is the x column, this is the y column, and this is the z column. Yeah? So now you just transform this matrix back to the system of simultaneous equations. Yeah? So you say 1x is x plus 2y, right? Minus 4z is equal to negative 4. This is the first row. Yeah? Now, the second one, 0 times x, so there's no x. Y minus z is equal to negative 2, right? And then here we have 0 and 0, we only have z, so it's 7z is equal to z. Okay, so now we can finally start working out for our variables. 7z, sorry, this is 7, not z. What am I doing? Okay, 7. There we go. So now I can start working out for my variables. So in this case, 7z is equal to z. We're just going to divide by 7, right? So z is therefore equal to 1. So that is our first solution. Now here, I'm going to replace this equation. I'm going to replace z into this equation. So it's y minus 1 is equal to negative 2, right? So therefore, y is going to be negative 1. That is our second solution. Now the third solution, we have x plus 2 times negative 1 minus 4 times 1 is equal to negative 4, right? So what is this going to equal? We have x minus 2 minus 4 is equal to negative 4. This is going to be then what? We're going to add 2, that's negative 2. Add 4, that's 2. So x is equal to 2. Okay, so let me just double check that just to make sure. Yes, okay, cool. So therefore, our x, y, and z are equal to 2, negative 1, and 1. And therefore, we are done. So now, which of the three cases is this? Do I still have the three cases written somewhere? No, I don't. Okay, so which of the three cases is this? This is going to be the unique solution case. Every single row has a unique solution. This one is 2, this one is negative 1, and this one is 1. Okay, so this is how you work out the entire like whole matrix system things for simultaneous equations. Okay, so now let's move on to the next one. So we've crossed out the unique solution. So what's left? We have the no solution case, and we also have infinitely many solutions. Okay, so we're going to move on to see how those two work. Okay, so now for our second question. So we're going to have the second question is 2x plus 3y plus 3z is equal to 3. And then we have x plus y plus 2z, negative 2z, sorry, so minus 2z, is equal to 4. And then 5x plus 7y plus 4z is equal to 5. Okay, so this is our system of simultaneous equations. Okay, so now we're going to put this into a matrix, right? So we're going to have 2, 3, 3, 3. Oh, first off, before we do that actually, um, I said that in the beginning, in the first question, I like to, when I have the first coefficient, which is the coefficient of x, when it's 1, I'd like to have that on the first equation. It makes things simpler later, so I'll just say x plus y minus 2z is equal to 4. And then the second one, 2x plus 3y, is plus 3z is equal to 3. And then the final one, which is 5x plus zy is plus 4z is equal to 5. Yeah, so this is my system of simultaneous equations. So now to set up the matrix, we have 1, 1, negative 2, and 4. Okay, then we have 2, 3, 3, 3, and then we have 5, 7, 4, 5. Okay, so vertical line, brackets around, and there we have our matrix system. Okay, so now we're going to do this. We're going to multiply this one by negative 2, right? Because we want these values to be 0 for now. So for row number 2, we're going to do negative 2 R1 plus R2 to get our new row 2. And then for row 3, we're going to do negative 5 times R1 plus R2 to get, sorry, plus R3 to get row 3. Yeah? Okay, and the first row doesn't change. That doesn't change. So that means I have 1, 1, negative 2, and 4. Okay? So negative 2 times R1. So that's what is that going to give me? So negative 2, 4, negative 8. And then my second row is 2, 3, 3, 3, and we're adding those together, right? So negative 2 plus 2 is 0. Negative 2 plus 3 is 1. 4 plus 3 is 7. And negative 8 plus 3 is negative 5, right? So I'm going to come over here and write that down. So 0, 1, 7, negative 5. Good. Now for my next one. I'm going to multiply the first row by negative 5. So it's going to be negative 5, negative 5, 10, negative 20, right? And then I'm going to add my last row, which is 5, 7, 4, and 5, plus negative 5 plus 5 is 0. Negative 5 plus 7 is 2. 10 plus 4 is 14. And then negative 20 plus 5 is negative 15, right? So I have 0, 2, 14, negative 5. Vertical line and the brackets to close it off. And that is my newer matrix system, right? Cool. So now moving on to the next step. Now I need to make this value over here 0, yeah? So I'm going to use my second equation because from the first question we solved, we saw that using row 1 to solve for this, like the third 0 doesn't work, right? Because it changes this value over here from 0, and we want to keep this as 0, okay? So we're going to solve for this third one. It's going to be this way. We're going to use, we're going to multiply the second row. And all right, we're going to multiply the second row by negative 2 and then add row 3, and that should give us our new version of row 3. Okay? So the second row multiplied by negative 2. So 0 times negative 2 is 0. Negative 1 times negative 2 is negative 2. And 7 times negative 2 is negative 14. And then negative 5 times negative 2 is 10, right? So then we have 0, 2, 14, and negative 5, right? Okay, so we add that. So we have 0, 0, and there we go. There's another 0 actually. And then 10 minus 5, 5, right? So that is going to give us what? 0, 0, 0, 5, 0, 1, 7, negative 5, and then 1, 1, negative 2, 4. Now, I don't even have to actually continue this. You can already tell, I'm going to continue, but you can already tell from this view that this is going to have no solutions. Why? Because if you look at it, you have 0, 0, and 0, right? The column, each column, this is going to be x, this is going to be y, and this is going to be z. For the last row of the system of equations, it's going to be 0x, 0y, and 0z. So that means it's just 0 equals 5. 0 doesn't equal to 5. It's just not true, right? So therefore, this linear system of simultaneous equations is inconsistent and it has no real solutions. So there we go. So now let me just write it like actually like how we're supposed to. So it's going to be x plus y minus 2z is equal to 4, right? And then you have y plus 7z is equal to negative 5. And then here you just have 0 is equal to 5. That just doesn't make sense. Yeah. So there we go. This is the second case that we have where you do not have a solution. Yeah, no solution. So the first one was a unique solution. We got three perfect x, y, z's. Yeah, three values for x, y, and z. In this case, we did not get a solution because the last row was 0 is equal to 5, and that's impossible. Yeah. So now we know that there's one left over, and that is the infinitely many solutions, right? So the infinitely many solutions. Let's look into how that looks like. Yeah, let's break down the question and see. So nice and zoomed in. Okay, so the last one is 2x plus 3y plus 3z is equal to 3. Then we have x plus y minus 2z is equal to 4. And then we say 5x plus zy plus 4z is equal to 10. Okay, so this is the last question. So again, I'm going to switch these around because it's just nicer on the system of equations. So it's going to be x plus y minus 2z is going to equal to 4. Then for our second one is 2x plus 3y plus 3z is going to equal to 3. And then we have 5x plus zy plus 4z plus 7y, sorry, not zy, what, is equal to 10. Yeah. If I, by the way, like say things out loud like incorrectly, but I'm like focus on what I'm writing down, because sometimes I don't know, I just mess up what I'm saying. Sorry about that. So this is our system of equations. Now let's set up the matrix system. So we have 1, 1, negative 2, 4. We have 2, 3, 3, 3. We have 5, 7, 4, 10. Okay, good. Vertical line, brackets to close it off, and this is our official matrix system. How are we going to do this? This is going to be negative 2, why do I say u? I think it's because of the sequences in series. R1, negative 2 times R1 plus R2 to get the new R2. For this one, it's going to be negative 5 R1 plus R3 is equal to the new row R3. Okay, the first row doesn't change, so it's 1, 1, negative 2, and 4, right? So this one by negative 2. So negative 2, 4, negative 8. Then the second one is 2, 3, 3, 3, and we add those together. So negative 2 plus 2 is 0, negative 2 plus 3 is 1, 4 plus 3 is 7, and negative 8 plus 3 is negative 5. This looks really similar to the question that we did before. I wonder what is the difference. Is there a difference? There should be. 2x plus 3y plus 3z is equal to 3. X plus y minus 2z is equal to 4. 5x plus 7y plus 4z is equal to 5. Ah, this one is equal to 10. That 10 makes a big difference. Okay, cool. So yeah, it's a different question. Okay, so then negative 5 times r1, so we're gonna have negative 5, negative 5, 10, negative 20. Yeah. And then you're gonna have 5, 7, 4, 10. We're gonna add those to each other, right? So 5, negative 5 plus 5 is 0. Negative 5 plus 7 is 2. 10 plus 4 is 14. Negative 20 plus 10 is negative 10. Okay, so 0 to 14, negative 10. Boom, brackets. Okay, good. Okay, cool. So now we need to turn this one into 0. Yeah, so as I already said before, you take the second equation to do that, because if you take the first one, then that changes this value of 0, and we do not want that. So we're going to do negative 2 u, oh my god, I keep on saying u, r2 plus r3 is going to give you the new r3. Yes? So row 1 and row 2 will stay the same. 0, 1, 7, negative 5. Now the last one. Okay, so negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 7 is negative 14. Negative 2 times 5 is 10. Now we add the last row. 0, 2, 14, negative 10. So we add them together. 0 and 0. Negative 2 plus 2 is 0. Negative 14 plus 14 is 0. 10 plus, so minus 10 is 0. Interesting. So you have 0, 0, 0, 0. So in this case, before we continue on to actually write it as, again, as a system of simultaneous equations, in this case, this is where we have the infinite solutions. Yeah? When you have two values equal to each other, 0 is equal to 0, yeah? You just have infinite solutions in this case. Yeah? It's just how it is. So when you see, for example, yeah, when you see something like this, it's just going to be the case of infinite solutions. So you have x, y, and z, right? So here in this case, you're going to have x plus y minus 2z is equal to 4. Then you're going to have y plus 7z is equal to negative 5. And then here you have 0 is equal to 0. Yeah? So this is true. And therefore, you have an infinite amount of solutions, and they are consistent. Yeah? Okay, so that's that. So that is it for the simultaneous system of equations, at least for the 3 by 3 system of equations. Yeah? So you have the three cases. Yeah, you have the unique solutions where you get three actual solutions for your x, y, z variables. Here is where you have no real solutions because you just get zeros, something like 0 is equal to 5, which is just not true. And here is where you have an infinite amount of solutions where something like 0 equals 0 shows up. Okay, so that's that for the simultaneous equation. Okay, so now let's discuss. So we discussed the 3 by 3 simultaneous linear equation system of simultaneous linear equations. And now we're going to move on to the 2 by 2. So the 2 by 2 is far more easier. Yeah, it doesn't require all of the whole matrix system and so on, like things like that. Yeah. So there's two main methods that, or well, there's three, but I'm going to be looking at two main methods. Yeah. So the three main methods are the graphical method. Yeah, so this you can do by your calculator. But what I'm going to be looking at is going to be the elimination method and the substitution method. I feel like, why do I feel like that's the wrong spelling? Substitution. Yeah, okay, that's correct. Okay, so let's look at an example for the elimination method first. So the elimination method, let's say that we have 5x plus 3y is equal to 9, and then we have 2x minus 4y is equal to 14. Okay, so the elimination method basically says that or the way that you approach it is that you multiply you multiply either one of or both of your equations by a number, by a constant, in order to match one of the values together in order to get rid of a variable. Yeah. So what do I mean by that? Well, let's say, for example, 3 and 4. Yeah. 3 and 4, if I multiply 3 by 4, I'm going to get 12. And if I multiply 4 by 3, I'm going to get 12, right? Now, if I have 12 on both sides and then I add both of these equations, yeah, then what is going to happen? Then I'm going to get rid of both, like, then y is just going to be out of the equation. And then I'm only going to have x to work with, which means then I can find x easily, then plug it into one of my original equations and then find y, right? So let's look at it like this. So let's say I'm going to multiply this by 4 and this by 3, okay? So 5 times 4 is 20. So as you have 20x, then you have here 12y, and then equals to 9 times 4 is 27, right? 27, oh my god, 36, excuse me, 36, right? Then you have 2x times 3, so this is going to be 6x, minus 12y, yeah, is equal to 14 times 3. 14, 3 times 4 is 12, 3, 1, 42, okay? So 42. Cool. So now that we have that, yeah, you can add both equations, yeah? So 20x plus 6x is going to give you 26x. 12 minus 12 is going to be what? Nothing. So you can just cross them out, okay? And then you have equal to 36 plus 42, 42, 36, that's going to be 8, 7, so 78. Yeah? Now if you divide both sides by by 26, so I divide this one by 26 and then this one by 26, this 2 crosses out, so I get x is equal to 74 divided by 26, which is, oh, it's supposed to be 78. I don't know why I wrote 74. 78 divided by 26, which is going to be x equals 3. Yeah, so I take x equals 3 and I plug it into any of the original equations. So I can plug it into this one, right? So I say 2 times 3 minus 4y is equal to 14. Yeah, 4y is equal to 14. Cool. So 2 times 3 is 6 minus 4y is equal to 14. So I'm going to minus 6. So that's going to be negative 4y is equal to 8. Yeah. And then I divide by negative 4. 8 divided by negative 4 is negative 2. Yeah. So for y, I get negative 2. Yeah. So therefore, x and y of this simultaneous equation, as a system of simultaneous equations, is 3 and negative 2. There we go. Okay? So this one is the first method. Pretty straightforward, pretty simple, pretty cool, pretty easy. Nice. Now, the other method is called the substitution method. The substitution method is where I have my two equations. Yeah, so let's say I have, scroll down. Yeah, so let's say I have 3x minus y is equal to negative 9. Okay? And then my second equation is 6x plus 2y is equal to 2. So the substitution method basically says that I take this equation over here. So I take equation 1. So I then make, let's say y, the subject, in 1. Yeah, in equation 1. So that means what? I'm going to move my 3x. So I have 3x minus y is equal to negative 9. So I'm going to move my 3x to the other side. So it's going to be negative y minus 9 minus 3x. And then I'm going to multiply the whole thing by negative 1 because I want it to be all nice and positive. So y is equal to 9 plus 3x. Okay? So this is 9. So this is y, sorry. So I'll take y and then I'll plug it into this equation over here. Okay, so I have 6x plus 2y, so plus 2 times 9 plus 3x is equal to, and that is equal to 2. Yeah? So let's expand. I have 6x plus 2 times 9 is 18, and then 2 times 3x is 6x, right? Is equal to 2. 6x and 6x is 12x plus 18 divided by 2. Right? Then I'll minus 18. So I'll have 12x is equal to 2 minus 18, which is negative 16. Right? So I have negative 16. And then I'll divide both sides by 12. So I'll get x is equal to negative 16 divided by 12, which is equal to x equals to negative 4 over 3. Yeah? So then after that, I'm going to plug x equals negative 4 over 3 into one of these. Yeah? And basically, I'm going to get y is equal to 5. Yeah, I have the solutions right here, and it says y is equal to 5. Because this is a fraction, it's not going to be nice to work with, and I don't really want to. It's really late, and I'm tired. So y is equal to 5. Yeah, so this is the substitution method. So based off of, which one should you use? I would say that the elimination method you should use when, like, if you have to multiply any of like the equations or whatever. Um, if the multiplication is simple, if it seems simple and it's easy to do, then I would recommend the elimination method. It's nice and quick and easy. But if you feel like you have to, multiply by bigger numbers, for the elimination method, then just, scratch that and just go on to the substitution method, yeah? So in this case, actually, this question, I think at least, fits the elimination method really well because you can just multiply this equation here by 2. But hey, it still works for the substitution method as well, yeah? So yeah, generally both methods are pretty good to use. You can also use the graphical method. You can either find another video explaining that or, read the book or something, because I won't be explaining that. Okay, cool. So, thank you guys for watching this video. That is it for simultaneous equations. I'll see you in the next one, depending on whatever the next one is. Bye bye.